Hello everyone. At first glance, math and music seem completely two different worlds. Math is all about numbers, formulas, and logic. Music, on the other hand, speaks through emotion, sound, and rhythm. But if we look closer, we find these two fields are deeply connected. Math helps us understand the structure behind the melodies and rhythm that moves us. Music theory is often called the grammar of music. Just as grammar helps us understand how words combine to make sentences, music theory shows us how different musical elements come together to create harmony and expression. It explains scales, the building blocks of melodies and chords, which add color, emotion. Intervals, the distance between the notes and rhythm, the timing that drives music forward. By learning these, musicians can create, perform, and talk about music with clarity and precision. But what role does math play in all this? Let's find out. The story of math and music connection goes back thousands of years to an ancient Greek philosopher named Pythagoras. According to legend, Pythagoras experimented with a single string on an instrument called a monochord. He discovered something fascinating. If you half the length of a string, the note it produces sound exactly one octave higher. The simple but powerful insight revealed that musical harmony is rooted in precise mathematical ratios. Pythagoras' works laid the foundation for centuries of exploration in relationship between math and sound. Let's dive deeper into how math shapes music. Scales like major and minor are built using specific frequency ratios between notes. For example, the perfect fifth, one of the most important intervals in Western music, has a frequency ratio of 3 to 2. By stacking these ratios, musicians create the characteristic sound of scales. Chords, which add richness and emotion to music, are also built using mathematical intervals. A major triad, the most common type of chord, combines a major third with a 4 to 5 ratio and a perfect fifth of 3 to 2 ratio on the top of the root note. Understanding these ratios helps musicians create complex harmonies that sound pleasing to the ear. Tuning systems also rely on math. The most widely used system today is called equal temperament. It divides the octave into 12 equal parts or semitones, allowing instrument to play in tune across all keys. This involves log calculation, a more advanced branch of math, to ensure each semitone is precisely spaced. However, some instruments can never be perfectly in tune due to physical constraints. So, musicians and instrument makers use clever mathematical compromises to solve this. Rhythm is another area where math is essential. Time signatures like 4/4 or 3/4 tells us how many beats are in a measure and which note values receives one beat. For example, in 4/4 time, there are 4 beats per measure and the quarter note gets 1 beat. This system uses fraction and simple math to organize musical time, helping musicians play together with perfect timing even when rhythm gets complex. Some composers take math even further by incorporating mathematical patterns into their works. The famous Fibonacci sequence, a series of numbers where each number is a sum of the two before it, appears in the music of Beethoven and Debussy. These patterns create a natural sense of balance and beauty, showing how math can guide artistic creativity. In modern music production, math is everywhere behind the scenes. Digital audio workstation or DAWs use complex algorithms to capture and shape sound. Sample rates like how many times per second a sound wave is recorded and bit depths with which precision of each measurement rely mostly on numerical values to deliver high quality audio. Digital signal processing techniques like equalization, compression, and reverb are based on advanced mathematical formulas shaping the tone and texture of music. MIDI or musical instrument digital interface sends numerical data about pitch duration and velocity to control digital instruments, giving producers precise control over every note and sound. Even musical notation software depends on math. Programs like Sibelius or Finale uses equations to position notes on staff precisely according to the pitch and rhythm. The length of beams, placement of bar lines, and spacing of notes all come from mathematical calculation based on fraction and time signature. Final thoughts. In conclusion, the connection between math and music is deep and beautiful. From ancient discoveries about vibrating strings to modern digital sound processing, math helps us understand, create, and appreciate music in all its form. The melodies and rhythm that moves as expressions of hidden mathematical harmony. So next time you listen to music, remember every note, every beat and chord lies a world of number and patterns. Thank you.